Greetings class, I'm Sir Mark and welcome to our another lessons on general mathematics. And for this discussion, we will tackle about what is real-life functions. Lesson 1. So, prepare your pen and paper for our discussion. Remember that you can pause, play, and rewind this video whenever necessary. What do you need to know? In this session, you are expected to determine functions and relation, illustrate function through mapping diagram, sets, graph, and represent real-life situation function. But before we continue to our discussion, let's first do some warm-ups. What's in? So, I have prepared a crossword puzzles with 5 descriptions of 5 different terms that is related to real-life functions. These 5 terms are necessary for us to proceed for our new lesson. So, let's begin. So, I will give you time to answer the following questions, and you can pause this video and just continue whenever you're ready or you're done answering. Okay, are you now done? So let's proceed to checking to see if your answers are correct. But if not, it's okay. Everybody made mistakes, especially in the first trial. Let's first answer the downcross puzzles, which are number 1 and number 3. Number 1. A rule that relates from a set of values to a second set of values. And the answer is relation. Very good. And number 3. Blank pair. Pair of an object taken in specific order. And the answer is ordered pair. Very good. And for our across puzzles, we have number 2, 4, and number 5. So number 2. The set of all x or input value. And the answer is domain. Very good. Number 4. Collection of all well-defined and distinct objects called elements that shares common characteristic. And the answer is set. Very good. Number 5. The set of all y output value. And the answer is range. Very good. Now, let's proceed to our discussion. What makes a relation a function? Function is a relationship between a set of inputs and a set of permissible outputs. Functions have a property of each input is related to exactly one output. Remember that to every x value must be related to only one y value. And that's the most important part of this lesson that I want you to remember. And that would be all to the definition of our function. Illustration will help us a lot to learn function easily. There are 3 ways to illustrate a function. First, by mapping, second, by set, and third, through graphing. Remember that a function is a special type of relation which each element of the domain is paired with only one element of range. First, we have mapping. Mapping shows how the elements are paired. It's like a flowchart of a function, showing the output, like this illustration shown above me. Now, let's identify if this is a function or not a function. Based on the illustration and by the definition itself, the illustration shows that it is a function because it is shown that every x value was paired in only one y value. Second example, let's identify this if this is a function or not a function. So, is this given is a function or not? So, this given is still a function. Why? Because it shows that in every element of our domain is paired with only one element of range, or our x value is paired with only one element of y. This type of given is called many-to-one correspondence. which means that we have two or more elements of domain that was paired with an element of range. I hope that's clear. Very good. For a third example, how about this given? Is it a function or not a function? So the answer is not a function. For this given has shown that there's one element of our domain that's paired with two elements of range, which clearly violated the definition or the rule of function, which state that every element of x must be paired with only one element of y. And this given is called the one-to-many correspondence. Now that we're done with mapping, let's proceed with the sets. Set. A set of ordered pairs in which no two different ordered pairs have the same x coordinate. An equation that produces such a set of ordered pairs is defined a function. For this example, we will have the set of Brewster notation. First example, we have the set of 2, 3, 4, 5, 5, 6, and 6, 7. Now, can you identify if this is a function or not a function? Very good. This is a function because there is no element of x that was input with two elements of y. Okay, second example. We have the given set of 3, 3, 4, 5, 5, 5, and 5, 4. Can you identify if this set is a function or not a function? Is it a function or not? Not a function. Very good. Because as we can see that our x sub 3 and x sub 4 has the same x value, which is 5 in our ordered pairs. And it has been repeated twice, which means that this is not a function. Well done. Now that we're done with the sets, let's proceed to the third way to illustrate and identify a function, the graphing. So how can we identify if the given graph is a function or not? For us to identify the given graph if it's a function or not is through vertical line test. Yes, function can be identified through graphing by the help of vertical line test. It is an imaginary vertical line that was used to identify a certain graph if it's a function, if it touches the graph only once or otherwise it is not a function. If the vertical line hits twice or more the graph point on the graph, then it is not a function. For example, how do we know if this graph is a function or not? Yes, we will use the VTL. As we can see, the VTL is the blue line there that hits our graph with only one point. Remember that the blue line is not a part of the graph. We only put that there to test if our graph is a function or not. And remember, you can move the line everywhere in the graph to make sure if the graph is a function or not. And based to our vertical line test, this graph is a function. So example number 1. Identify the given graph if it is a function or not a function. Alright, are you now done? Let's check if you got it right. Remember that you can move the line according to your will to test the graph if it's a function or not a function. And there you have it. It is a function. Very good. Okay, now let's try for more examples to make sure that you can identify a graph if it's a function or not. Go ahead and take all the time that you need to identify which are functions or not a function. Okay, are you now done? Let's check your work. So, as we can see, there are 2 out of 6 given graph that is a function, and there has 4 given graph that was not a function. Very good, you have done a very good job. Functions in real life. We have 3 real life application of function. First, the circle. The circle belongs to the function of diameter. Second, shadow. The shadow belongs to the function of one side. And third, when we drove a car. From the distance where we begin to the distance when or our destination, it is called the function of time. That would be all for this session. Great job, everyone. Thank you for your time and God bless. Happy holidays.